Okay, now we continue with our second part of this chapter. All right. So sampling and hypothesis testing. So last video we covered on basic sampling nodes. Okay. All right. So last video we covered this, right? Term, annotation, purpose of sampling, sampling technique, and now we will cover a few more on sampling. Okay, but then we will give you a few example here. So hypothesis testing will cover in our video part 3, right? Okay, so first one we have to know what is the mean and standard deviation of the sample mean. As I told you before, you have a population. From that big population, you want to choose a random sample. So from that random sample, we are going to calculate what is the mean and what is the standard deviation. Okay, so let x1, x2, and x up until xn be a random sample of an independent observation from a population with mean, mu, and variance sigma square. Okay, remember? Alright, so sample mean x bar is defined by x bar equals to this. Alright, so from this mean, sample mean, where xi is a random variable with mean, mu, and variance sigma square. Okay, so we can find the mean for the population, EX. Okay, so EX, E1 over N, X1, X2 plus everything, then you will have this. Okay, so this box is from the previous, so I just want to remind you what is the denotation for size, mean, variance for sample and population. Okay, so from here you will get the mean, the mu, right? And then for the variance, you have this, okay? Variance x bar equals to variance 1 over n, multiply everything, and then you take out that 1 over n square because this is variance, all right? And then we solve everything. Then you found that your variance is sigma square over n, okay? So this step, basically, you don't have to memorize, okay? What you have to know is just what is your mean and what is your variance, oh? Just take out the formula. All right, so the mean and standard deviation of the normal population. Okay, so normal population, still remember, right? Normal, when you have a normally distributed. Okay, so x1, x2, xn are independent, where your n is given by mu. Okay, mean, and this one in the second in the bracket is the variance variable. Then the distribution of x bar is exactly n mu sigma square over n, no matter what size of n is, where x bar is given by this. Okay, and then the standard deviation of the distribution of x bar is given by sigma over square root of n. Okay, if this is your population, okay, this will be your sample, all right, x bar. Okay. Okay, let's look at the example. A random sample of size 20 is taken from a population. Okay, so you have a population which is normally distributed with mean 60 and standard deviation 4. All right, so before that, remember, where is it? Okay, so the first one, n mu sigma square, is for our population. N mu sigma square over n is our sample. Okay, so back to our example. Random sample size n. Okay, from a population you choose 20. Okay, size 20 is taken from a population where your population is normally distributed by 60 and standard deviation 4. Find the probability that the sample mean is less than 59. Okay, what does it mean? Okay, so x is normally distributed where your mu is 60 and your variance is 16. How we get 16? From the standard deviation 4 square. All right, so your sample mean is given by this formula, right? Remember from the previous slide, mu sigma square over n. You want to build the expression for your sample. Okay, so mu will be the same 60, while variance for your sample is given by sigma square over n. So 16, right, over 20. 20 is from your sample size 20. So now you have this 60, and then you simplify the variance. Now your mu is 60, and then your variance is 4 over 5. Okay, so now the question is to find the probability less than 59. So x bar is for our sample. Okay, x bar less than 59. Okay, so this is normal distribution and we want to standardize. Okay, we have to standardize before we can use the normal distribution table. Okay, so how we standardize? That x we minus with mu over with our standard deviation. Okay, less than, so 59 minus 60 over standard deviation, 2 over set 5. 2 over set 5 come from here, 4 over 5. Okay, square root, right? So x minus 60, x bar minus 60 over 2 over set 5 is your z. So it's already been standardized, so we write as z, not x bar anymore. Alright, so this one you use your calculator and then you get this negative 1.118. Okay, so you get the probability is 0.132. So how they get the value? That you have to apply the method that you learn in normal distribution chapter. Okay, use the normal distribution table. Okay. Okay, I just put this table in case you forgot what is your mu and then what is sigma square stand for x bar s squared, right? Okay, next we look at central limit theorem. What is central limit theorem? If x1, x2 up until xn is a random sample from any population with mean mu and variance sigma square, then for a sufficiently large n, sample mean x bar is given by mean mu and variance sigma square over n. Okay, and then the approximation gets larger as n gets large. Alright, so what is central limit theorem? Okay, I give you an example. Okay, you have a population, okay, a very big population. You have so many raw data, and then from that raw data you choose a few sample. Okay, so now I'm choosing randomly 10 data. I took out 10 data, 98, 107, 105 up until 103. Okay, so now I have 10 raw data from my big population. Okay, so now I find the mean. So how I find the mean is summation of the raw data divided by how many are there? N equals to 10. Okay, now I get 101.2. Okay, so what does this tell you about the population mean? Mu. Mu is for your population, right? Okay, so therefore, to estimate how far is your mu from 101.2, where this is your sample mean, you need to know about the spread of data. Remember how to look at our spread of data? We look at their usual parameter where it is a standard deviation. Okay, standard deviation. Okay, so central limit theorem states that for a sample size n drawn from any distribution, okay, how many distribution you have learned? Normal distribution, Poisson distribution, what else? Binomial distribution. With mean mu and variance sigma square, the distribution of the sample means is approximately given by this. Okay, n mu sigma square over n. Sigma square over n now is your variance for your sample mean. Okay, for sufficient large n. Okay, let's look at the example. Okay, so basically this is a very short video. Okay, so now you have a random sample of size 40 is taken from each of the following distribution. Find for each case the probability of the sample mean exceeds 6.1. Okay, X Poisson. So this is the Poisson distribution, 6.4. What does 6.4 stand for? That is your mu, right? Your mu. Okay. And then Bx binomial 10 is your NP. NP is your mu. 0.6 is your NPQ, your variance. Okay, let's solve it to find what is the probability for the sample mean x 60.1. Okay, so this is your population. All right, so now you have to find the expression for your sample mean. Okay, sample that you have randomly chosen here. So mean is mu 6.4, variance is sigma square 6.4 as well. Why is it equal? Check back based on your lecture note in Poisson distribution. Okay, the same size is large, so by using central limit theorem, so we find the expression for normal distribution. Okay, so x bar. Okay, so this is your 6.4 mean. All right. Okay, 6.4, and then sigma square is 6.4 divided by n, 40. Now you have x bar normally distributed, where your mean is 6.4, and then your variance is 0.16. Okay, so in order to find the probability, you have to standardize before you can use the normal distribution table. So x bar minus 6.4, so this is your mean, okay, divide by standard deviation. Okay, so x bar, so this x bar is for this one, and then 6.1, you standardize 6.1 minus 6.4 divided by set of 0.16. Okay, now your x bar already standardized, so we write as z. Okay, and then z is greater than negative 0.75. Then you apply the method that you have learned in normal distribution, use the normal distribution table. Then you found out that the value is given by 0.7734. Okay, sample mean is given by this, all right? And mu sigma square over n. Okay, so same thing, second one. Also, this is the last one. All right, so binomial ex mu np. Okay, 10 equals to 10 times 0.6, so equals to 6. And then variance is npq, so this is your p, this is your q. All right, and then so this one is 2.4. Then we have to find the normal. Okay, so from this mean 6.4, so by using central limit theorem, so sigma square is 2.4 divided by 40, random sample just now is 40, and then 6.4, 2.4 divided by 40 is 0.06. Okay, now you have the mean and the variance, right? And then we want to find probability exceeds 6.4, then we standardize, right? So x bar, x minus 6.4, this one should be 6 over set 0.06, and then you standardize to 6.1 minus 6 over set 0.06. Okay, and then you calculate, and same thing, you calculate using, you look through the normal distribution table, then you found out that it is equals to 3417. Okay, so that's all for the second video. So I'll give you more example later on in the next video. Thank you.